So this video is a review of Bayes' rule. Suppose that we've got these two discrete random variables and we have these pieces of information about their distribution. The question is, how can we compute this probability using the Bayes' rule? And this probability is not given explicitly up here. So let's take a look and review Bayes' rule. So this is what Bayes' rule tells us. It relates conditional probabilities together, and we can derive Bayes' rule in a pretty straightforward way by analyzing the joint distribution of x and y. I can write my joint distribution this way, and I can also write my joint distribution this way, conditioning on x. And if I have my left-hand side and my right-hand side and just ignore the middle here, if I move my probability of x to the denominator, then I've reconstructed the Bayes' rule. So let's apply the Bayes' rule to compute this probability. Well, Bayes' rule tells us that this quantity is just going to be probability that x is equal to 0 given y is equal to 1 times probability that y is equal to 1 divide by the probability that x is equal to 0. I think I did it right. So I flip my conditional probabilities, and my numerator is the same as this one, and my denominator should be x equal to 0. All right, so that's good so far, but here's the problem. The problem, first of all, is that none of these terms are given to us here. Some of these terms are actually you might already see how to get. So for example, probability that y is equal to 1, that's just going to be 0.3. Again, we're assuming that x and y are Bernoulli random variables, and they can only take on the value of 0 or 1. So I've got this term here. And same thing here, that probability that x equal to 0 given y is equal to 1, well, that's going to be 0.2. But the problem is, what about this denominator? And here's what we typically do. What we typically do is marginalize. We look at, all right, what is the probability that x equal to 0 conditioned on y equals to 0 times the probability that y is equal to 0 plus probability that x equal to 0 given y equals 1 times the probability that y is equal to 1. So that's something that we can do, and we do have all of the required quantities here. So this quantity we know is 0.2, this quantity we know is 0.3, 0.7, and this quantity is just 0.61 minus this one, right? So we've got all of our pieces here, and we should be able to plug everything in and complete our computation.